What if a black hole appeared in our solar system? Silence, then a sudden flicker in the dark. In the cold emptiness beyond Neptune, a ripple cuts through the void of space, invisible, relentless. Something has arrived. A distortion in reality itself. A black hole. Tiny yet infinitely dense. Silent yet more powerful than anything we have ever known. And it is moving toward us. What happens now? Space is vast, empty and unforgiving, but it is also fragile, delicately balanced. Every orbit, every rotation, every gravitational tug works in perfect harmony to hold the solar system together. Planets dance around the sun like clockwork, their paths carved by the steady pull of gravity. For billions of years, this balance has endured. But what if one day it did not? What if a black hole, an object born from the death of a star, where gravity becomes so extreme that even light cannot escape, appeared right here inside our solar system? Would Earth survive? Would the sun itself endure? Or would everything we know be consumed? To understand what would happen, we must first understand what a black hole truly is. A black hole is not a hole at all. It is a point, an infinitesimally small region of space where matter has collapsed under its own gravity to infinite density. This point is called the singularity. Around it lies the event horizon, the ultimate boundary. Once crossed, nothing returns, not even light. Black holes come in different sizes. Some are small as a single atom. Others are millions of times more massive than the Sun. At the center of most galaxies, including our own Milky Way, lies a supermassive black hole, quietly holding everything together. But the one appearing in our solar system would not need to be massive to cause chaos. Even a black hole just a few times the mass of the Earth could destroy everything we know. Because black holes do not just pull, they warp space and time itself. Let us imagine it happens somewhere beyond Neptune. A dark sphere no larger than a marble drifts into our solar system. It gives off no light, no sound, no heat. Its presence is known only by what it does. Neptune, orbiting quietly at the edge of the Sun's reach, begins to wobble. Its perfect circular path twists ever so slightly as a black hole's gravity pulls at it from afar. At first, astronomers think it is a mistake. Their instruments detect something massive, but invisible. Within weeks, the anomaly becomes undeniable. Something unseen is exerting an enormous gravitational force. Telescopes find nothing. And then the calculations confirm it. A black hole has entered our solar system. How dangerous this event becomes depends on one question. How close does it get? If the black hole remains at the edge of the solar system, perhaps orbiting beyond Neptune, we might survive it. It would disrupt planetary orbits, sending comets and asteroids off course, but life on Earth could continue for a while. But if it drifts inward, toward the inner planets, then catastrophe begins. The black hole's gravitational influence would overpower the delicate balance between the planets and the Sun. Orbits would stretch and distort. Planets could collide or be thrown into deep space. Even before reaching the inner solar system, its gravity would pull countless asteroids from the Kuiper belt, sending them hurtling toward the Sun and Earth. A storm of destruction, invisible but unstoppable. Month 1. Astronomers confirm the black hole's approach. Governments issue global alerts. Scientists race to calculate impact zones while satellites begin to fail as gravitational distortions ripple through space. Month 6. The black hole crosses the orbit of Neptune. The planet's magnetic field fractures. Massive tidal forces pull at its icy atmosphere, sending frozen plumes drifting into the dark. The solar system's outer harmony begins to break apart. Year 1. Uranus and Saturn start to drift from their orbits. The gravitational tug-of-war between the Sun and the black hole twists their paths into ellipses. Asteroids rain inward. Jupiter, the giant guardian of our solar system, begins to shift position, its protective influence collapsing. The solar system becomes a cosmic storm. Year 3. The black hole moves inward, approaching the asteroid belt. It consumes rocks and dusts, silently and visibly. Planets begin to tilt and wobble. On Earth, tides rise unpredictably. The Moon's orbit wavers as Earth's path around the Sun distorts. The sky no longer looks familiar. Constellations drift, seasons falter. Year 5. The black hole passes between Mars and Jupiter. The gravitational chaos becomes uncontrollable. Mars is thrown off its orbit, spinning wildly into the void. Jupiter pulls against the intruder, but it is useless. The Sun trembles. If the black hole passes close enough, it begins to feed, not on planets, but on the Sun itself. Accretion begins. Matter from the Sun's outer layers spirals inward toward the black hole, forming a glowing disk of radiation hotter than anything in the known universe. Light dens around it, twisting into strange halos. For the first time, humanity sees the shape of its destroyer. We have seen this happen before, not here, but out there in distant galaxies. Astronomers have witnessed stars torn apart by black holes. The process is called spaghettification, matter stretched and shredded as it falls into the gravitational abyss. We have seen binary star systems where one star orbits a black hole, feeding it until it shines brighter than 1,000 suns. But in our solar system, such an event would be final. There would be no recovery, no adaptation. When the Sun begins to lose mass to the black hole, its gravity weakens. Planets drift outward, escaping its control. Earth would freeze, drifting into darkness, its oceans turning to ice. Or worse, the black hole could pass close enough to devour Earth itself. Imagine the moment it happens. From the surface of Earth, the sky would distort. Stars would stretch into long arcs, light bending around an invisible center. The Sun would dim, not setting, but warping, twisting into strange patterns. Then darkness. As a black hole pulls the Earth apart, everything we have ever built, ever loved, ever known, collapses into a single point, smaller than a grain of sand. No explosion, no sound, no trace. Just silence. The solar system, the planets, the Sun, the comets, the moons, all drawn together into one final, infinite fall. In the end, what remains is nothing but the black hole itself, glowing faintly with the radiation of what it consumed. An echo of everything that once was. It is a terrifying thought that everything we are could vanish so easily, swallowed by the universe itself. Yet, black holes are not villains. They are part of the natural order. Without them, galaxies would not exist. Their gravity shapes stars, organizes galaxies, and even helps seed new worlds. They are the engines of creation, as much as they are the symbols of destruction. Perhaps if a black hole did appear in our solar system, it would not be the end, but a beginning, a transformation into something new beyond our understanding. In the distant future, another civilization might look upon this black hole and find traces of us, our atoms, our light, our story woven into its endless spin. Because nothing in the universe truly disappears, it only changes form. So what if a black hole did appear in our solar system? It would be the end of everything we know. but perhaps the start of something greater than we can imagine. The universe is vast, its rules are ancient, and its mysteries endless, which leaves us with a haunting question. If a black hole could appear out of nowhere, what else might be waiting in the dark?